Hello, welcome back. So now I am going to do another problem in my 5th tutorial. This is a challenge problem, so it's a little bit difficult and I might just do a variation of it. So it says there's a well-known diagram which illustrates that the cardinality of the rational numbers is equal to that of the integers. So this means that we can put the rational numbers in one-to-one correspondence with the integers. Okay, so we are asked to construct a function f of x which takes a positive integer x and produces the rational number corresponding to figure 1. Well, let's have a look. So if I scroll down, it's this picture, right? So the first one is 1 over 1, the second rational number is 2 over 1, the third rational number is a half, the fourth rational number is a third, and so on. So we follow this diagram like a snake, and we can capture all of the rational numbers. In fact, you'll notice that 1/2 is equal to 2 over 4, which is 3 over 6, 4 over 8, and so on. So 1/2 appears in this diagram infinitely many times. Alright, so this says that there are, well, a one-to-one correspondence with the integers. Okay, so let's get back to the question. Construct a function which takes a positive integer x and produces the rational number corresponding to figure 1. That's kind of a hard problem, right? So what I'll do instead is construct a recursive function, because I think that will be helpful for you to learn how to build functions that are slightly more complicated than the ones we've done earlier. Alright, so I'm going to view these rational numbers projectively. So rather than write 1 over 5 or 2 over 6, I'll consider it as a pair, 2, 6. Okay, so what I want to do is from 2, 6, produce the next term in the sequence, and in this case, it's going to be 3, 5. Right, so that's the exercise I'm going to do. All right, in Mathematica, that is. So we'll open it up, and we'll make a few observations first. All right, so if we're going to build a recursive function, we want it to take in a pair and output the next pair in this sequence. All right, now you'll notice that if the first term is equal to 1, well, then what happens? The next term is just 1 comma y plus 1. All right, also, if looking down this column here, if the y value is 1, then the next term in the sequence is going to be equal to, well, it's going to have x value 1 greater than the previous term, right? Unless x is even. Okay, so if x is even, then we go this way. All right, so how can we do this with an if statement? So let's write just that. So let's first of all consider the top row. Okay, so I'm working with pairs x and y. Okay, so now, but rather than work with exactly x, y, I'll work with pairs, and I'll call it, so let's just think of it as a point P. Okay, P, and we've got the first component of P and the second component of P. All right, this is a pair. Okay, so this is actually just equal to P. If P is a 2-tuple, then what I've got here, this is just P. Okay, now, like we said before, we need some if statements. All right, so if, all right, so I've just written that there, and now I want to start writing an if statement. So if P1 is equal to 1, then, okay, now this is where I put what to do if the first thing is true. All right, so if it's true, I do this. If it's false, well, then I say what to do after the second comma in the case that this is false. Okay, so if it's equal to 1, now I want another condition here. Whoops. What's happened there? I don't know what that is, so I'm just going to get rid of it and rewrite that. If, okay, brackets, P1 is equal to 1, and I want to put an and another condition. Okay, what is the other condition? The second value, so P2 is even. Alright, so the question, is this number even? Okay, so I can write even Q P2. Alright, so if both of these are satisfied, then what I want is, I want to just put P1, comma, followed by P2 plus 1. And if not, well, look, I'm going to try this out first, right? So this is not quite the full function I want to write. What I'm going to do is just test it out along the way, and then I will build a function to do everything that I want. All right, so if not, if this is not satisfied, then let's just put a string. Yeah. All right, so up here to test this out, I'll put P equals 2, 3. All right, and I'm expecting to get yeah. Let's see. All right, 2, 3, yeah. So that means that this is not satisfied, all right, which is exactly what we expect, because 2 is not equal to 1. Okay, so that part of it is working just fine. Now let's try 1, 3. Okay, we still get yeah, and why? Because 3 is odd, it's not even. All right, so look up here, 1/3. Now 1/3 should go down, it doesn't go across there, so this is still what we want. All right, so let's change this to a 4, and we hope now to get 1/5. All right, yes, that's fine. We get 1/5. Okay, so this little bit works. All right, so now rather than put yeah, what I want to do is put in here another if statement. All right, because there are other possibilities, aren't there? So let's say if now I put in 2 commas, right? So what are we saying? If, I'm going to look down the column now. So I'm copying this, but I'm going to change it. All right, so if P2, the second component, now down the columns here. All right, so if the second one is equal to 1 and I want the x component, or the first entry, to be odd, to proceed that way. So I'll put odd cube. Okay, now what do we want to do? Something like this, but not quite. I'll paste that in there. Right, so what are we doing? We add 1 to the value of, or the x component, or the first entry of the pair. And otherwise, let's say nope. Alright, so try. What do we get? Well, 1, 4, so the first thing is happening. We add 1 to the 4 and get 1, 5. Okay, so that's fine. Now let's try it out. We put 3, 4. We get nope, that's good. Alright, what if we have 3, 1? Alright, that gives us 4, 1. Just like what we see right here. 3, 1 goes to 4, 1. Okay, so that's working so far. Now what about 4, 1? I hope that gives nope. Yes, good. Alright, so these two parts are working, the boundaries. Okay, so next, rather than nope, I want to put in another if statement. Right, if, comma, comma. Now what are we testing? So, let's say, well, I haven't thought about this properly yet, so I'm thinking right now. Alright, so let me just place myself right here at 2/3. Okay, 2/3. What do I want to do? I want to go this way, to 1/4. So what am I doing? I'm subtracting 1 from the x component, adding 1 to the y component. Alright, so this is, well, I go that way when the y component is odd, right? Yes, okay, so if P2 is odd, so I'll put odd Q. If odd Q that, and is that the only condition? Well, this is, we don't need to worry about what happens on the left and top edge, because this part of the program only gets activated when x is not equal to 1 and y is not equal to 1. So we don't actually need this. Right, so I can just say what to do if the y component is odd. Okay, so then I want to output, where were we? So I was at 2/3 and I want to subtract 1. So the P1, I want to subtract 1 from that. P2, I'm going to add 1 to that. Okay, and if this is not the case, let's put nope again. Nope. Okay, try it out. Alright, so 4, 1. 4, 1 goes to 3, 2. Yes, that's correct. Alright, because it's going this way. Alright, so what about 4, 2? Nope, so 4, 2 should go the other way. Okay, so this should be our last case to deal with this. So rather than nope, we want to put if. Now, when should we go the other way? So previously we went up and to the right, and now we want to think about going down and to the left. So we should do this when the second component is even. I'll put my 2 commas in there. Okay, so even Q. Alright, now what should we do when the y component is even? Well, we should add 1 to the x component, P1 plus 1, and subtract 1 from the y component, P2 minus 1. And let's put nope otherwise. Right, but there shouldn't be any nopes. So where were we? 4, 2, 4, 2. Where's 4, 2 in this diagram? 4, 2 goes to 5, 1. Okay, that looks good. All right, so this should handle all cases. Well, I don't need this. Right, now what I want to do is turn this into a function. All right, so now that I know that it's working, I'll go clear P, and then I should get some error signs. Yes, good, because P is cleared. Now I want to write a function, but I need a name for my function. So I'll flip through my book. Cyril, that's a great name, Cyril. And it will be a function of P. Alright, so P underscore colon equals module. Alright, now I'm going to put some local things. Let's make X and Y local variables. Well, actually, you know what? I haven't set it up that way, so that's fine. I'll leave them out. I'll just leave an empty set of brackets. Okay, so it takes in P and then it does all this to it. Right, so copy this, paste it here, paste, and now I can get rid of this. Alright, semicolon, and let's try it out with a pair. Okay, so Cyril, and I'll enter the pair 5, 3. Try it out. I get 4, 4. Does that agree with the diagram? 5, 3. Where's 5, 3? 5, 3. 4, 4. No, it doesn't agree with the diagram. And why not? Because there are more conditions to this, aren't there? So I was a little hasty with that. Right, I was looking at the Y component and saying, well, it just goes that way. But that's not totally the case, right? Because you look down here and the 3 is odd, and my instruction said go up and to the right, but that's not what I want. So instead, I'm going to have to fix my code in 2 of the cases probably. All right, so let's consider this again. 2, 3. Well, the 3 is odd. All right, the 3 is odd. What happens in this case? Well, that is only going that way when the Y component is odd and the X component is even. All right, so there are only 2 of these cases, 2 arrows going that way and arrows going that way. All right, so 2, 3. Can we think about the sum or the product? All right, so 2 plus 3 is 5, which is odd. All right, 5 plus 3 is 8. It's going that way, so I think I can just deal with the sum. All right, so let me test that. 2 plus 4 is 6. All right, so all of these add up to 6, don't they? All of these add up to 7. They're going that way. Yep, okay. Okay, so I need to modify my code, and what I'm going to do is, rather than say go that way when Y is odd, it seems I have to do it when the sum of X and Y is odd. The sum of the first and second components. So I have to go in here, let's see, I believe it should be this. If odd Q, copy this, paste it here, plus, okay, P1 plus P2, if that is odd. Now I'm going to copy this and just use it again and place it right here. Alright, so I'm hoping this works now. Let's have a look. Yes, 6253. Does it go to 62? Yes. Okay. Let's try out 54. 54 goes to 45. Is that right? Yep, that's correct. 54 goes to 45. 37 should go to 46. 37 goes to 46. It seems like it works, okay? Seems like this code works. Now I've got a working function which recursively gives me the next term in the sequence. Okay, so now I want to program with this, alright? So first of all, since I got this, I want to say p equals 1, 1. Alright, semicolon, and then I want p to go in here. Now I'm going to say p equals 0 of p. Right? Why? Because I'm going to recursively construct that sequence, this sequence right here. Okay, so, well, one of the easiest ways to do that is to tabulate. Now, tabulate these. Alright, and now I can tabulate over, say, the letter J. J goes from 1 to, let's take the first 12 of these and see what we get. Alright, so we have 2, 1, 1, 2, 3, 1, 2, 2, 3, 1, and so on. Alright, so that looks like the sequence. Alright, so all I would want to do to get this perfectly correct is prepend it. Prepend. I want to put in front the first term of the sequence, which was 1, 1. Alright, let's see. Okay, very good. Alright, and now let's just turn this into an n, and I'll say n is equal to 15. Alright, so now I can set how far I want to go. That, and so there we have it. That's it. It computes the first 15 terms of this sequence, and the sequence is the one that associates the integers with the rational numbers. Alright, so let's see how far we can take it. Let's go 150. Alright, sure, great. So the 150th term of this sequence should be 15, 3. Alright, if that were viewed as a rational number, that's the number 5. Okay, very good. I'll stop there. See you next time.